Python. Python is one of the most popular programming languages in the world, largely because it is relatively easy to read and write. Its syntax is designed to be simple, which makes Python especially popular among beginners. But Python is far more than a beginner's language. It is widely used for artificial intelligence, machine learning, data analysis, automation, scientific computing, and web development. Python also has an enormous ecosystem of libraries and frameworks. Instead of building everything from scratch, developers can use existing tools for tasks ranging from analyzing huge data sets to creating AI models. The main weakness of Python is performance. Python programs are generally slower than programs written in languages such as C++ or Rust. However, its simplicity and huge ecosystem often make development much faster. C++ is almost the opposite of Python. It is significantly more complex, but it provides developers with much greater control over how a computer uses its resources. C++ is known for its high performance and is commonly used when speed and efficiency are extremely important. It appears in game engines, operating systems, desktop applications, browsers, financial software, and many other performance-critical systems. One of its biggest advantages is low-level control. Developers can work directly with memory and carefully manage how programs use hardware resources. The downside is complexity. C++ gives programmers a lot of freedom, but that freedom also means there are many more ways to make difficult mistakes. JavaScript. JavaScript is one of the fundamental languages of the modern web. Whenever you interact with a website, clicking buttons, opening menus, filling out interactive forms, or watching content update without reloading the entire page, JavaScript is often involved. Originally, JavaScript was mainly used inside web browsers. Today, however, it can also run on servers, desktop computers, and even some embedded systems. Its enormous ecosystem has made JavaScript one of the most widely used programming languages. Developers can build entire web applications using JavaScript and technologies built around it. Its biggest strength is versatility. Its biggest weakness is that the language and its ecosystem can sometimes feel complicated and inconsistent. Java has been around since the 1990s and became famous for the idea of writing code once and running it on many different systems. Java programs normally run through the Java Virtual Machine, which allows the same general program to work across different operating systems. Java became extremely popular in enterprise software, large backend systems, and Android development. It is designed to handle large applications with millions of users and complicated software architectures. Java is generally more verbose than languages like Python, meaning developers often have to write more code to accomplish the same basic task. But that structure can also be useful when working on enormous projects where organization and maintainability are extremely important. C#. C# was developed by Microsoft and is closely associated with the .NET ecosystem. It is used for many different types of software, including desktop applications, web services, cloud applications, and especially video games. One of the most recognizable uses of C# is Unity. For years, Unity has made C# one of the most important programming languages in game development. C# combines many features associated with modern programming languages while still providing strong performance and a large ecosystem. It is particularly attractive to developers who work with Microsoft's technologies, although modern .NET also runs across multiple operating systems. Rust is a relatively modern programming language designed to provide both high performance and strong memory safety. This combination is what makes Rust particularly interesting. Traditional low-level languages can be extremely fast, but programmers have to be very careful when working with memory. Rust attempts to prevent many common memory-related bugs before the program even runs. At the same time, Rust does not rely on a traditional garbage collector, allowing it to remain suitable for performance-critical software. Rust is used in systems programming, command line tools, networking software, browsers, and other areas where reliability and performance matter. Its main disadvantage is its learning curve. Rust rules can be difficult to understand at first, especially for developers coming from simpler languages. Go, often simply called Golang, was created at Google with an emphasis on simplicity, performance, and efficient software development. The language has a relatively small set of features and a straightforward syntax. This makes Go easier to learn and maintain than many more complicated systems languages. Go is especially popular for backend services, cloud infrastructure, networking tools, and distributed systems. One of its most famous features is Go routines, which make it relatively easy to run many tasks concurrently. Go may not provide the same level of low-level control as C++, but its simplicity can make large networked applications much easier to build and maintain. Swift. Swift is Apple's modern programming language for developing software across its ecosystem. It is commonly used to create applications for iPhone, iPad, Mac, Apple Watch, and other Apple platforms. Swift was designed to be safer and more modern than Apple's older Objective-C language. It includes features that help developers catch certain programming mistakes earlier while still providing strong performance. Swift also works closely with Apple's development tools and frameworks, making it a natural choice for developers building native Apple applications. Its biggest limitation is its ecosystem focus. I mean, if you want to build specifically for Apple's platforms, Swift is extremely useful. If you want to create software for many unrelated platforms, other languages may be more versatile. Or